We're so glad to have Ashwin back with us. He was here with Zoomcar in 2019, and we are so glad that there was a chance, Sri Lankan expedition that could bring him all the way from UAE to Kochi for discussing about engineering velocity and using DevOps for accelerated success. He's someone who has a startup experience complemented by Big Four consulting. Ashwin has experience with Fortune 500 companies as well as mid-market services businesses. He's an IoT expert and an avid cyclist. With a very thunderous round of applause, can we invite Ashwin Murali on stage, please?
Hey, good morning, everyone. Thank you so much for having me here. Right, I'm sorry about my throat. My doctor said I shouldn't be doing any more beer, but I tried toddy, it didn't work. So this is where we start, right? This is when Digi said, hey, we need to do a talk, I want you speaking at AWS Kochi. I said, okay, I'll bring the most boring topic that I can think of and bring it in front of you people, see how you react. This is the first time I'm doing this talk. Depending on how quickly I can put you people to sleep, I'll see if I can continue with this or not. So this is the boring talk you all deserve, right? As DevOps practitioners, as managers, as engineering leaders, this is a talk you think you don't need, but you really need to hear me out for the next 25 minutes. Now, why are you here and what do you walk away with? The idea, the clicker is not working. Right. The idea that I'm trying to sell today is everyone is looking at DevOps the wrong way. Everyone thinks DevOps is about the tools, but I'm going to sort of flip this over on your heads and tell you how DevOps is going to work or has to work. You know this TikTok trend, right? Thanks for the few laughs that I got, right? So the idea is to make your org look proper, not just the DevOps team, not just the engineering team. And we're going to focus on DevOps from one particular angle, which is engineering velocity. Now, why am I the right person to talk about this? I have been working with AWS for about 15 years. 2007, 2008 was when I started working on AWS. I've been scaling startup tech for multiple startups. It's been 5 Series A to Series B startups that I've scaled. I've worked from traditional data centers to cloud native to hybrid to now I'm back living inside a data center at 4 degrees. I run my own email and DNS servers. I represent the Abu Dhabi AWS user group. Any of you folks come down there, feel free to give a shout out. We'll be more than happy to host you. I do a lot of talks. It's usually around cloud, but I've also been, my recent talks have been around org design, scaling, engineering, and so on. And right now in my current day job, I have fun building autonomous vehicles in the UAE. That's one that we're currently spending most of our efforts on. It's a legit Formula One race car. The idea behind this is, yes, hard tires. It was just before we put it on our test run on the Yas Marina circuit. So Formula One people, you know the Yas Marina circuit, right? That's the last race of every season. Now the fun part of this car is it is expected or it is required to hit north of 300 kph every lap. It's completely autonomous. If you can spend a few seconds peering, squinting at the image, you'll notice there's no cockpit, there's no steering wheel. That car drives itself. Our job is to sit and watch and pray that the car just drives itself and doesn't do anything else. We get the fattest read-only view of data from that car, and there's a racing league. It's called the Abu Dhabi Autonomous Racing League. It includes Formula One, it includes dune racing, and it includes drone racing. It's coming up in April. I'm not here to sell the race. You people will definitely know. Dijesh and a bunch of folks asked for information when it comes out, and I'll do that. A couple of questions that we're trying to answer with regards to this race, right? The first question, how do we win this? There are 10 other competitors that we have. Now, this is the biggest question that we're trying to answer. What exactly is the requirement here? I mean, yeah, the car's got to drive itself. It's got to hit 300 kph. It's got to turn. It's got to brake. It's got to avoid other cars. It's got to avoid the barriers on the side. It's got to avoid the audience. When it comes in for refueling, it's got to avoid the pit crew, right? How do we handle the software? How do we handle the hardware? How do we handle the unknowns? What we get is a car which is standard across 10 different teams, but what we put inside and how we drive that car is up to us, and our team is doing its set of tech. Sorry about that. How do we handle pre and post processing? For us, post processing or whatever analytical dashboards that you talk of in the SaaS universe, they're completely useless to us, because after the car is done its lap, there's not much we can do. Right? We're trying to figure out how to update the machine learning model on the fly, how to update the car's network on the fly, the car's offsets on the fly, right? Those are the kind of problems we're trying to figure out how to solve. There is a live component, there is an AR and a VR component. If you've got a Samsung or a Sony VR headset, you can sit in the cockpit of the car and enjoy the race. You don't need to be in the stadium, or you don't need to watch it on TV. You can literally be in the cockpit. If you've got a PS5, we are also looking at an integration where you can race against these 10 physical cars in a virtual lap, right? This is what we're doing. Now, one of the fun parts, right? One lap of this car on Yas Marina gives us about 20 gigs of data. Disaster recovery, do you know it works? Backup is not disaster recovery, right? Now, let's flip this, right? Deploying for deployments requiring approvals, you call it lead time for changes, right? Deploying on a Friday night, I'm going to call it deployment frequency. Roll back, roll forward, change failure rates. Does anyone see a pattern here? Disaster recovery, I'm going to call it mean time to recovery. You know what these 4 points are? Someone? How is it part of DevOps? Good, it's part of DevOps. Thank you for reminding that in a DevOps conference. But that is the most boring answer someone could give. What? Are you serious right now? These are called Dora metrics. They're called Dora metrics. This is not the Dora cartoon from, no. These are called Dora metrics. These are metrics which are Google's definition of how a North Star engineering organization should be defined. Google up Dora metrics, you will not get the cartoon. Right? Now, here's what I just did. I just took an engineering organization, took a DevOps metric, and crammed it in. The reason is this. Every part of engineering now requires DevOps. And this is the case I want to make today. I want you people to stop thinking of DevOps as an auxiliary team. If there are managers here, I want you people to stop thinking of DevOps as an add-on function. DevOps is an engineering team just as much as development is or QA is. And it's an organizational team. It's not a cost center. It's an integral engineering function. That is the case we're building today, right? Now, how do you do this? There is a dev team, there is an ops team. You've heard of this, right? Devs are from Venus, ops are from Mars, or wherever else they can come from, right? And then there is some voodoo that happens in between. Now, that voodoo over time has this name. It's called communication. When you heard the keynote talk, right, from HiFX, the idea is every time DevOps implements something, engineering needs to know what is happening. Every time engineering wants something, DevOps needs to know why something is coming in so that they can provide the most viable solution. The most common issues where this happens is someone comes to a conference like this, they see Prashant talking about why we should do serverless first. They'll go back and say, let's do serverless. and 5 months later that entire organization is burnt to the ground. Jokes apart, no, these are not, no, the sad part, and Prashant will definitely agree, people make these mistakes. They don't look at the nuances of why you should do serverless first. You can start with serverless, but there is a point at which you should know that serverless is no longer my solution. Or you can start with EC2s first, and you should say, okay, EC2s may be too costly or maybe too irrelevant to my solution. I can go to serverless because it's a small cron job that I'm running repeatedly, right? So you need to know what to do. Now, the whole DevOps evolution, let's fast forward like 10 years, 15 years. Let's come to where we are today, right? These are the standard terms that we work with. You're working with immutability. What do you call that? Containers. Please wake up. You're working with ephemeral systems. What do you call that? I call it Fargate. You people can call it Kubernetes. Infra as code. I call it CDK. You can call it Terraform and Helm. You have automation. You have self-serve systems. This is your CI/CD pipelines. This is your deployments. Your going from git push to trigger to build to test to deploy, right? Now, there is a common theme here. If you notice, every bit of engineering work is involving DevOps here. You are setting up, this audience is setting up and enabling the entire DevOps team. And as an extension is enabling the engineering team to deliver value to customers, right? One thing that you should all take away, if you can, would be the first point on this slide. When you build systems, when you're talking about Kubernetes, when you're talking about containers, when you're talking about Lambdas, the idea is this. I want you to think about letting the system fail, right? You have so much capability on AWS that if a container fails behind a load balancer, no one is going to know outside the load balancer. Trust me, I've done this multiple times. I have switched load balancers in production when the systems were hot, and customers still won't know. You'll just see one small curve like that, and then everything is back normal, right? Don't let the fear of failure get to you. But the more important thing is to know how to recover fast. If things are continuously failing, then you have a problem. That's when your metrics dashboards come in, right? Now, when you look at things, are you seeing a pattern of ops being involved earlier or not yet? How is this happening in your organizations? Does DevOps get called when the PRD is being written? Try it, it works, right? Because when you do that, you are provisioning capacity, you're provisioning compute, you're provisioning architecture based on requirements. You're not doing it as an afterthought. And that is how you reduce operational overhead on a day-to-day basis. AWS conference, right? So I'll give you an AWS stat. Do you know how the DevOps ratio works in AWS? The last known publicized ratio was 10,000 compute units, physical compute units, managed by one personnel. That is the AWS ops to infra ratio. So if you think that you need a massive DevOps team because the project is massive, no. My own team, the autonomous racing team and the autonomous robotics center, 150 research engineers, 90% postdocs, 3 DevOps engineers. And we work 7 hours a day, that's it. You need to know how to optimize for value creation instead of saying, I will add more people, I'll throw more people at the problem, right? But here's where things are going to get interesting. Engineering is not going to do ops, right? How many engineers here? Any engineers in the crowd? Hi. Right, so do you people do DevOps? Interesting. DevOps, how many of you people go write code, fix bugs? Hey, you are an exception. Right? But here's what I'm advocating for. When engineering and ops works together as a combined engineering team, engineering gets better because they know what ops is doing. They know why a particular capacity for a compute unit has been decided. If someone says we will use a Lambda because this is a repeated job, we can run it on a cron using EventBridge or something, they know that this gives you a specific execution pattern basis which they have to write the code. They're not going to write a full Java application and say, okay, fine, Spring Boot it in a Lambda, right? Same thing, Ops gets better because Ops now understands engineering and says, okay, you want to run just a function. You want to take a job from a queue, move it to another queue. You don't need a full Spring Boot application. I'll give you an auto trigger Lambda, right? And this is going to get you enhanced capability across the organization, and that is the first step to increased engineering velocity and higher quality of deliverables. Think about it. You know exactly how you want to deliver value. Ops and engineering are working together saying, let's agree on the right common ground instead of saying, hey, I want a server, right? But it's going to affect org design. Why? Because you're going to say each service now will require a specific style of application development, specific style of architecture for it to operate efficiently on the cloud. Systems with background jobs can run on Fargate, can run on Lambdas. Systems with big data can run on SageMaker or an EMR cluster. Your search goes on to OpenSearch. So now all of these are not one system. They are one offering to your customer, but internally, once you go into the AWS console, there are different services. There are different components of your technology handbox, right? So now, what is going to happen is the DevOps value, and you will see this if you have already not seen it, you will see this happen, where value provisioning per team is going to change. A team which uses an OpenShift cluster is not going to need the value provided by a Lambda, or a Fargate container, or an EMR cluster, right? Now, you're going to write different pieces of infrastructure to suit different services or different offerings. And as you do that, because you're using infrastructure as code, you start checking in, you start seeing repetitive patterns. That is going to lead to consolidation, and one of the senior management is going to say, let's make a platform team, right? This is how DevOps is required to evolve in an engineering organization. We spoke about new architectural patterns, right? There are going to be patterns where there are patterns that you've not seen. There are patterns you're going to see. There are patterns that you will see are going to repeat across your organization. Multiple teams will have multiple services which will have multiple databases. Now, one of the things that you can do is, let's take all the databases, give it to a DB team, let them run it. You're going to see observability as a standard requirement across multiple systems. So you're going to say, okay, fine. Observability becomes one Helm chart plugin or one deployment component. Let's just tag it with different teams, and then you send it out as an offering, right? So now you start commoditizing offerings. You will start seeing a pattern where there are Lego blocks that are offered to you, and then you just build on top of it. You just keep stacking infrastructure, you're stacking applications, you're stacking businesses on top of it. And then obviously, yes, microservices. How many microservices proponents here? Show of hands. How many of you people love microservices? Okay. Hey, no, Prashant, you don't get to say this. Lambdas, man, they're not even services. Now, this is a warning. There's going to be, there was a different variation of a talk where I was speaking about platform teams in Abu Dhabi. This manager said, hey, you're doing A, B, C, D. Why don't I directly jump to the last step? I mean, yes, burn your company down. Thank you. So, and that is the reason why I mentioned this line here in a dedicated slide. Never start with a platform team. Platform team is a very evolutionary aspect of engineering. It happens because of how your organization is structured, how your engineering is structured. If you have doubts about this, you should go and Google for something called Conway's Law. Check it out. Conway's Law tells you that your organization is going to impact how your engineering is structured. I have 5 minutes? Lovely. So I'm going to quickly rush now. Don't build a platform team and then bring engineering. It's never going to work. Platform team should always focus on commoditizing engineering requirements. Okay, your function is to provide value. Your function is not to go and say, hey, I have something, do it. You will get kicked out. right? Remember, enhanced capabilities are why you're building platform teams, right? Standardizing to muscle memory is probably the only point I would like you to take away from here. The other things are standard, right? You have SLAs. When you say database, you say that my team will offer you databases with 100% uptime because I'm running on RDS. How the database is provisioned is immaterial for the engineering team that's using it, right? Which brings us to operations. I'm not going to complete the full deck. I'm going to stop at operations and we're going to say thank you. The most irritating part of operations is this, right? You're going to have an infra team, you're going to have a platform team, you're going to have a software or application team. Now, each of these teams are going to move at a different velocity, right? You need to figure out life cycles as an organization. You cannot release infra daily. Infra will be a monthly release probably. Platform, where you consolidate databases, you apply security, you apply image hardening rules and things like that, might be a weekly or a bi-weekly release. Application could be a multi-release per day cycle. So the infra cycle versus the platform cycle versus the app cycle is not going to be the same, right? You will see friction, and the way to solve for this friction is reduce the size of deployments. Don't wake up one morning and say, okay, we're changing from Postgres to MySQL. That's not how things work, right? Increase the iteration frequency. When you are operating as a platform team, instead of saying, I am giving you one image every 6 months, tell them that I am adding patches once a week. Get that muscle memory in, and then you can space things out. Increase compatibility. So one of the things I've learned as a platform team is you should always have 3 versions of your system running at any point in time. One for the team that cannot move fast, one for the team that says, okay, fine, I'll do it, and one for the team that says, okay, bring it on. Right? Focus on contracts. Focus on making sure that your delivery has 0 breakages. How quickly can a system go from version 1 to version 2 or back to version 1 is what is going to define engineering velocity at its peak, right? Always remember, the layer above works basis stability of layer below. So application requires a solid platform, platform requires solid infra. And that is how you define velocity. The stronger your foundation is, the easier it is for teams above you to move faster, right? Remember that image. You need to take it into 3 different layers at the least. Increase communication. Now, this is something I wanted to tell you people, like, talk to not just dev. As a DevOps person, talk to architects, talk to product, talk to business, understand what value you're providing, question your assumptions. If you can do event storming, I'm going to ask you to Google it up and try it out. Always have tight alignment, always have loose coupling, operate only on SLAs and contracts, deliver promises, and the last part, de-risk, right? Iterate to the finished product. Don't say, I'm giving you something. Say that I'm going to start giving you things. Let's do one step at a time on a daily basis, right? Constantly reevaluate, constantly rebuild, constantly deliver value, and just keep deploy, man. And this is what I wanted to say. DevOps is never about tools. It's a thought. It's about how you get your engineering moving. Stop being an enabler. Stop being an integral part of that entire wave, right? Don't say that I do CI/CD, so I'm a DevOps engineer. I don't care about CI/CD. I'm a DevOps engineer for a living. I've been one for 18 years. Right now, my current job is to go into a data center and switch on machines and switch them off if they heat up. So it's not about the tools. It's more about how do you enable and how do you integrate into engineering to deliver value. And with that, thank you. Thank you so much for your time. You've been an amazing audience. Thank you.